Hello everyone, I am Veena Gandhi, Assistant Professor from Department of BCA Science, Abeda Inamdar Senior College. In this video, you will learn structure of a C program. The topics covered in this video are basic structure of C program, example of C program, compilation process of C program, assignment on above topics. C is a structure programming language. Structure of a C program is easy to read, modify, easy to document, and makes it consistent in a format. The basic structure of a C program is mainly divided into 6 parts or sections. The first is documentation section, second is link section, third is definition section, fourth is the global declaration, fifth is the main function, and subprograms. Now, first section is documentation section. In this section, programmer documents about the program like objective of the program, name of the programmer, date of creation and time, etc. It is specified at the start of the program in the form of comments. Now next, precursor or link section. All header files are included in this section, which contains predefined different library functions. Now copy of these header files is added into your code before compilation process. For example, every C program contains #include stdio.h. This standard input-output header file contains the predefined functions like scanf, printf for input and output statements. Now this function has to be linked with the user's program. So a link section contains all the header files which having extension .h. Next section is definition section. It includes the preprocessor directives. Preprocessors are the programs that process our source code before the compilation of C program. Now, these directives start with hash symbols. For example, hash define directive is used to create symbolic constant. Now, preprocessor replaces all these symbolic constant with its value or defined code. For example, suppose hash define pi and its value is 3.14. So every symbolic constant pi will be replaced by the value 3.14. Our next section is global declaration. The global declaration section contains global variables, function declaration, and static variables. Variables and functions which are declared in this scope can be used anywhere in the program. Main function. Every C program must contain main function. For every C program, the execution starts from the main function. It is compulsory part to include main function in every C program. The main function contains 2 parts, declaration part and execution part. In declaration part, we declare the variables, functions, arrays, structures, etc. In execution part, it contains the statements like assignment statement, looping statement, different function call, etc. Both these parts are included in the opening and closing braces. Next section is subprogram section. This section includes the user-defined functions, which may be called from the main function or other user-defined function. When the user-defined function is called from the main function, the control of the program transfers to the called function, and when it encounters the return statement, control return back to the main function. Let us see example of C program. Now first section is documentation section. It contains comments. In comments, we can add file name, programmer name, description of the program, date and time. Now comments start with / and asterisk and end with asterisk and /. This section is optional part, but it is good practice to add the documentation in the form of comments so that anyone can understand the program's objective. Next part is link section. It contains all the header files. So here #include stdio.h file is included, which contains the standard library functions like printf, scanf, etc. Next part is definition section. It defines all the symbolic constants. So here we define the symbolic constant by using the #define directive and symbolic constant name is born and having value 2000. After that, it contains the global declaration section. It contains the global variables or function declaration. So we declare here function called as age, which accepts the current age and returns the age of the returns the age. Next part is every C program contains main function. So here main function contains declaration part and executable part. Now in declaration we declare the variables here, and in execution part we contains a statement. So here printf statement is there which prints the age, and here call the function user defined function age. When this function is called, control is transferred from the main function to user defined function, that is subprogram section. Now in subprogram section we define the user defined function. Here we write the code for the function age, which accepts the current year and returns the current age of the any person. So when it comes to the return statement, again control is transferred from the user defined function to the calling function main. Now every C program may contain or may not contain all the parts, but every C program must contain main function. Next topic is compilation of C program. When you type a program in a VI editor or Turbo C editor, that program has to be saved and compiled and then execute to get the output. So compilation is a process of converting the source code into object code. This process can be done with the help of what system program called as compiler. So compiler checks your C program for syntax errors. If there are errors, it shows the errors. If the program is error free, then it generates the object code. For example, here C program is shown after converting it in when compiler accepts this program and convert into object code in the form of 1 and 0. This is in C compilation. As you see in the diagram, source file is given to preprocessor. Preprocessor process all the directives and expand the code. This preprocess file is given to compiler. Compiler converts preprocess file into intermediate assembly code. So intermediate assembly code is given to assembler to create the object file. This object file is given to linker for linking the header files, and we will get finally executable code. So in C compilation there are 4 phases: pre-processing, compilation, assembling and linking. Let us see all these phases in detail. Now first phase is pre-processing. The source code which is written in a text editor like VI or Turbo editor and saved as a file name .c. Now this source code is first passed to the preprocessor and then preprocessor expand this code. In expansion, it removes all the comments, it processes all the symbolic constant, it includes the header, it includes the code of the header files in the program. This preprocessor code is stored in the file name having extension .i. After expansion of the code, the expanded code is passed to the compiler. The second phase is compilation. In compilation, the compiler converts this preprocessed code into intermediate assembly code. It is stored in a file name having extension .s file. Assignment, short questions. What is the purpose of link section? What is the use of global declaration section? Third, justify every C program contains main function. You can try this long question as an assignment. Explain the structure of a C program. Explain the C compilation process. Thank you for watching this video. Next phase is the assembly. In this phase, the intermediate file having extension .s is taken as the input and turned into file name .o by the assembler on Unix platform. This file contains a machine level instruction. At this phase, only existing code is converted into machine language, but the predefined functions like printf, scanf are not resolved yet. So in linking phase, these functions are resolved. The next phase is linking. This is the final phase in which all the linking of function calls with their definition is done. Linker knows the location where all these functions are stored or implemented. So the output of the linker is executable file. In DOS, the extension of exe file is .exe, and in Unix, executable file can be named as a.out. So C program goes to different phases in compilation: pre-processing, compilation, assembling, and linking.